Okay, guys, let's look at these. Turn this into an ether. Oh, Williams and ether synthesis, yeah?
Does the sodium work on a primary alcohol like that, or should you use another reagent?
Sodium works on any alcohol. Question? Well, you need a deprotonate, and then you need a carbon electrophile.
So like for instance, something where
You can have ethyl bromide.
okay.
You could use diethyl sulfate, like we did in lab. Question? I can't hear you. Still can't hear you. I remember that Leonard Skinner concert when he's like, I can't hear you. That was back in 1973 in Atlanta. I'm having a hard time following you, team. Ask me after class. It's pretty straightforward. Williams and ether synthesis. There's a variety of leaving groups you could use. I heard you say tosylate. Yeah, it could be a tosylate. Oxide is going to give you an alcohol product. Any questions about the first one? 3 carbon on the side chain, only 2 carbons on the side chain. We've lost a carbon, cleavage, alkene cleavage, ozonolysis. We get this product. Plus another product. What would be the other product?
Aldehyde. It's another aldehyde.
With what on this carbon? Ah, 2 H. What's that called? Formaldehyde, yes. Right? This carbon becomes carbonyl, but there's 2 H's there. Yep. Oxide reacting with a nucleophile, strong nucleophile, backside attack. Proton transfer, O minus takes the H from the nitrogen. Sadia, how we doing? Any questions about that one? Pretty straightforward. SN2, least steric linear site, backside attack, proton transfer. Osmium followed by magic step. What does this make? Cis-diol or synaddition. Okay. You can draw this with the bonds. The methyls are trans. The phenyl is back with the methyl. Put the 2 OHs either straight up or straight down. Either way, you're going to get an enantiomer. Draw a Fisher projection of this. I get this. Rotate it with methyls at top and bottom. I get OHs on opposite sides, and that is what? 3O.
Yes.
How we do? How we do with drawing the Fisher projection? Any questions about that? Everybody got that right? Good. I don't believe that. But, moving on. Starting with 1-propanol. Okay, well, when you do synthesis, you want to start with you want to go backwards. At least until you see how you're going to go there. It's a ketone. How do you know how to make ketones?
Oxidation of secondary alcohol.
You know two ways, but one way involves cleavage of an alkene. And remember, when you do synthesis, you typically don't want to cleave a larger molecule. So ozonolysis is not great for synthesis, although in specialized cases it can be. Another way, oxidize secondary alcohol, yeah? Yeah. Very common way. So really, can you do this? Can you take it back to the alcohol? If you had this, could you make that? Yeah, one of the big three, right? Okay. Well, now the chore becomes, how do you make this alcohol? Well, any alcohol with more than 2 carbons can be made from what? Epoxide. Nucleophile carbon-carbon OH. Can you see a nucleophile carbon-carbon OH? Yes. I can have a 3-carbon nucleophile and then I can have an epoxide. For example, I could have this nucleophile and then epoxide. Use anything you want as long as you start with 1-propanol. So, would this react with this? Would water work up to give that? Yeah. This nucleophile would attack the carbon, oxygen would leave. How do you get such a nucleophile? Well, that comes from like a Grignard, right? Okay, how do you make Grignard? Something like this with magnesium metal. Okay, how are you going to make this? Alcohol, PBr3. There's other ways to do this. You could have made the chloride. You could have made an alkyl lithium instead of a Grignard. Did anybody do it another way? Questions?
How liberal can we get with like the Grignard reaction? Because I added like
How liberal can you get with?
I added the last 3 carbons with the oxygen. That was hydroxyl group, and all I had to do was add KNO4 under acidic conditions to get it to ketone. So it was pretty easy, so to say. Would that work?
I didn't see what you're talking about, but I don't understand. You had an alcohol out here?
I had 3 carbons added to the original reaction.
I don't know. Do you want to show it on the overhead? Or do you want to show me after class? Okay.
Is it wrong to do a weight synthesis with something that's essentially you put the product and cleave it?
This one down here?
For that reaction, if I did a weight synthesis,
I don't see an ether. This is not an ether.
but then can I cleave the ether because you get that?
How would you make the ether?
I guess the thing I would be making is very close to that. So I guess
You made this, converted it to an ether, and then converted it back?
No. Like for the original product, I didn't remember the PBR step, and so I tried making it into an ether with something that very much resembled the product, and then I cleaved said ether.
Sounds suspect.
Yeah, it's.
Show it to me, okay?
Yeah.
Both of these sound suspect. Anybody can show me something afterwards. Question?
Well, yeah, I'll show you after. Can I ask it? I don't know.
Uh-huh.
Okay. So I kind of skipped the magnesium step, and I just was. Can you react it as an SN2 using like a bromine and then?
The bromine here?
Yeah. So that bromine acts as like a leaving group, and then I just reacted like an anion. So like of the whatever we were adding. So like the OH and the phenol. So where you had a nucleophile come in, I had like lithium plus and then.
I mean, what did you have? You had this,
And then one more bond.
you had this,
Oh, no. Sorry, no, you were right. Take off the bond.
You had that?
Yeah, and then react.
Reacting with that?
Yeah.
Okay, how'd you make this? You didn't need to because you started with that? Okay, well, I mean, you started with this, you eliminated, okay. The problem is that this is unreasonable.
Oh.
That's a strong carbanion. It's just going to do a proton transfer, and you're going to get the H here. I mean, that's essentially, what you're essentially doing is, you're telling me that you're going to treat this with base and pull off an H and make an anion. But that's more acidic, right? So I don't know how you're going to make this. I reckon it says any other reagent is necessary, but... Is that where we're talking about being liberal? You can't just use anything. I mean, any other reasonable reagent? Okay, anybody wants to show me what they put? Okay. When we do more multi-step synthesis, during test 4, there will actually be numerous correct ways. Right now, I don't see many other ways other than maybe doing chloride here and then maybe doing lithium here instead. If anybody has a good way, I will say yay and I'll share it with everybody else. Okay, how we do? Test on Monday. I did get them, they're going to delay the Super Bowl. It's going to be on Tuesday instead. Okay? I talked to them, headquarters. Okay? I've been giving tests on Monday after Super Bowl for 15 years, guys. Okay? It will be on Monday. Okay, what do we want to do? Do we want to do more multi-step synthesis?
Yes.
One of these, the ones in the workbook, you have the answers. Do you want to do one of these that we've not done? Did we do this? I think we did that. Did we do this one?
Not that one.
We've not done this one?
What packet is that?
Epoxide packet? We've not done this? Okay, what way do you know to make an alkyl chloride? Alcohol. Okay, let's take it back to an alcohol. So if we had this alcohol, Jordan, you're saying you could make that here?
Yeah.
What would you react this with?
HCl.
HCl?
Yeah.
Okay, it actually will be okay. I mean, that's secondary knowledge. It's secondary. It's benzylic. It's probably, it may be either SN1 or 2. What else could you use other than HCl? PCl3 or thionyl chloride. It'll work also. Okay. Since it's second, this was a primary chloride, you probably wouldn't want to use HCl, although, okay. You can argue that it might still work by SN2. All right, so now the job becomes, is there another way to make chloride? There actually is. I mean, we could take it back to the alkene. Could you react the alkene? What would you react it with? Actually, also HCl. That's the organic 1 reaction. Where would you make cation at, left or right? Yeah, attack H+, cation, chlorine attacks cation. Well, how are you going to make an alkene? alkenes commonly made? Elimination of a leaving group. What do you want, so how do you want to make it? It'll make it from this and maybe do an E2?
Yeah.
Yeah.
So you have this, you eliminate, and then you add the acyl back?
Isn't that the?
Or if you had this, we can eliminate basically alkenes typically come from leaving group. I don't think that's a good way to go. We got an alcohol here. What could we do here? What are we going to start with? Now start with an alkene.
Yeah, I can make it
Epoxide.
Yeah, you go to epoxy.
Yeah, carbon, carbon OH attached to the
So
top.
what nucleophile do we need? Carbon, carbon, OH, we need that nucleophile?
Yeah.
Yeah.
So you react that with, or you put that with bromine.
So I can make that, at this point I'm just going to say, okay, well you could continue to come back. You could say I'm going to this epoxide, what would we react this with? Need that carbanion. Need that Grignard, isopropyl magnesium bromide. Would these two give that?
And acid.
Workup with acid, yeah, appropriate workup. How are you going to make the epoxide? From? Yeah. So wherever you can draw that to that over there, MCPBA. Make the epoxide, react it with this Grignard, give this with workup, and then convert the OH to chlorine. Then if you're trying to make the alkene, how would you make it from here? That is, how would you make the alkene? Lolly? Caleb? That's good old organic one, the elimination, right?
One question here.
How do you convert this to the alkene?
Just use the base and H2.
Strong base? Yeah. Like potassium terpetoxide or something? E2? E2?
Yeah.
Yeah? Why are you act so shocked about that?
I have a question.
No, E2, standard E2. Final exam guys is comprehend, it's going to be half of organic 1. Okay? That's standard E2, right? Okay. Question?
Okay, is there any way that you can make the alkene into an anion and have it attack on like an isopropyl iodine?
No, these H's are not acidic. No. H's are not acidic. Did we do all these?
We didn't do the one below it, the one at the bottom.
The one at the bottom is similar to the one on the test. Take this back to what?
And alcohol.
Alcohol. So if you had that, you would do what? Something like chromium trioxide, H+. How would you make this?
H2SO4.
Keep me in on things.
What handout is this? Is multi-step synthesis in? Oxide handout? Okay. What epoxide? Carbon-carbon OH. So we want that right there. We have, this epoxide plus what?
Methyl.
Like what? Methyl magnesium iodide? Yeah, just a methyl. Methyl attacks, opens it up, workup gives you the H there. Methyl nucleophile, right? I mean, that's the nucleophile, CH3. And then you oxidize it. Somewhat similar to what was on the quiz there. Let's look at NMR handout. Second page of the packet. When we first looked at this, a while back, yeah?
Yeah.
Can you now tell these two alcohols apart by proton NMR?
Yes.
Hopefully very easy now, yeah? Any questions about NMR?
Can we finish looking at the comprehensive one we did yesterday? Because I think we got to a product, but then you said it
Yeah, I
wasn't
did.
the
I
right
thought there
one.
was something we needed to do. That was in the pre-core form-up,
Yeah.
which by the way did not have any mass spec on it, although it asked you to show a mass spec. Okay, there will be mass spec typically on the comprehensive problems like in the workbook. We didn't even look at the carbon NMR yesterday. What was the product? It was a para-substituted, I think we had a phenol. What do we have? Looks like there's an ethyl, a singlet. What was coming off here? Oxygen or no? Was it that?
Yeah, that's what we had.
Is that what we had?
That's what we had.
Was there another compound that would sort of match everything?
I think that's what we were trying to come up
Did
with.
someone come up with another compound that would match the, especially the proton NMR?
Yeah.
Somebody said yeah?
Yeah.
What'd you get?
I'm pretty sure it was the ethyl where the OH was, and then the oxygen right off the phenyl. So in the right corner, there's the ethyl group,
Just ethyl?
yeah, and then in the opposite, it went oxygen, then the carbon, and then the OH off the carbon.
That there?
Yeah.
Okay, you got your ethyl, that's your triplet quartet. You got a singlet here. Where would you expect, okay, this is your quartet, right? Quartet 2H. I agree, I did quartet,
Yeah.
2H. Where would you expect this at in the proton NMR? Peak position.
Very upstream.
Very upstream?
Yeah.
Well, it'd be downfield. It's benzylic, it's about 2 to 3 ppm. Where's our quartet at?
4.
4.
Seems high.
If it's at 4, it's typically bonded to it like oxygen or nitrogen or halogen. 2 to 3 is your benzylic next to benzene ring or next to carbonyl. Next to oxygen or nitrogen, it pushes it more down to like 3 to 3.5, 4. Both of these look like they're bonded to, in your table, it's had something like CH bonded to like a Z group. And the Z, they said it was halogen or nitrogen or oxygen. That's the problem I see with that. Also, this CH is next to 2 oxygens. So that singlet 2H, I would say that's probably going to be like a 5 or 6. It's like doubly deshielded with 2 oxygens. So splitting fits, but peak position I don't think fits quite as well. There's another structure though. Somebody got another structure? I think, let me see if I can draw it, if this is it. Instead, how if we put that oxygen there? And make this just that. Is that the right formula? Yeah. Okay. Now we got the ethyl, and this is a quartet 2H, but it's next to oxygen, so this is going to be where? About 4, which is where we're at. Here's our singlet next to oxygen, about 4. Then the triplet is not as far downfield, and then you got the OH, which is D2 exchangeable. That can actually be variable. This is actually it. This here is very darn close. That ppmi is not good. The positioning is not good. Which one matches the chemical test? Chemical test is what, Jones?
Yeah.
It says it's positive Jones. Which one would be positive Jones? Primary alcohol definitely would. Phenols, they may give a positive Jones. So the chemical test doesn't distinguish between these well, but this definitely gives a positive Jones. Question?
So you said earlier that the quartet, because it was right next to the benzene ring, that it would be benzoic. But then in the structure that you just drew, even though it's next to the oxygen, would it still be benzoic because it's still next to the ring?
Well, that's benzoic because it's next to the ring.
Right. So wouldn't that be 2,3 as well?
No, but it's also bonded to oxygen.
So it'd be a little bit more.
You can't ignore the fact that it is bonded to oxygen.
Okay.
It may be a little bit more downfield, but indeed, look, see, it's like 4.5. That's probably because it's not only next to oxygen, but it's also next to the benzene ring. Where typically, next to oxygen is usually more like 3 to 4. So it's a little bit more because it's like, Jordan?
That's what you got. So, okay, if you have a heteroatom, like despite that H on the alcohol group that's near a carbon, that has things, that will always be a singlet, right? Because it's bound to a heteroatom.
Like we said, we'll say again, you typically don't get splitting between oxygen and nitrogen. So this is singlet 2H. There's no neighbor here, and you just don't see the neighbor on the oxygen. OHs and NHs typically do not split, especially in this class.
And so with the H on the alcohol group as well, that doesn't split either.
Well, if this is not split, then that's not going to be split.
Okay.
Because it has to go both ways. They're either both split or they're both not. They're either talking to each other and they both get the consequence, or they're not talking to each other. Up there. What's another chemical test that may distinguish between these two? Because this is a regular alcohol, and this is a phenol. How could you distinguish between the two? Well, tolerance is just looking for aldehydes. Neither one would give a positive tolerance.
PCC.
Question?
I was gonna say lupus test.
Well, the Lucas, that's what we did, right? Oh. Jones. Lucas.
With HCl and C4.
Okay, yeah. Lucas, where you're looking at, Lucas primary and second, no. Lucas tertiary gives the fastest Lucas. What's it, tolerance? Tolerance is aldehyde, right? Neither one would give a quick Lucas. I mean, this is going to be pretty slow, although it is benzoic. possibly it might, Lucas is SN1, right?
Yeah.
Yeah, that's definitely not going to do any SN1. This could do an SN1, resonance cation makes this like secondary, possibly. Here's another one, let me tell you this, and it's in some of the problems in the workbook, probably at least one of them. You can react this with sodium hydroxide. Both of these are probably solids. Which one will dissolve in sodium hydroxide? Your phenol will dissolve in sodium hydroxide because sodium hydroxide will deprotonate it, make the anion. Typically it will dissolve in water. Will a regular alcohol react with sodium hydroxide? No. To deprotonate a regular alcohol you have to use like sodium or sodium hydride. So solubility in sodium hydroxide is a test for phenols and how you can distinguish the two. Phenol is more acidic. And that is a chemical test that's mentioned in one of the spec problems in the workbook. Pretty sure it is. Carbon and NMR, we haven't even assigned peaks. Let's see. What does this mean, SSDD? TTQ. That's the splitting you would get if we had splitting. So I'm giving you that. It's free information. If we label these as A, let's do carbon, A, B, C, D, E, F, G, where that's just C prime and D prime. Which one is A? Might be a little bit difficult. What are these two here?
Probably A and F.
This is A and F. I don't know which is which. They're right on top of each other almost. They both be, if we had splitting, would they both be triplets?
Yeah.
Two H's on the carbon, triplet. Okay, what is this guy here?
G.
That's G. Why is it a quartet with splitting? Because there's three H's on G. The H's on the carbon split. What are these two? Not only are they short, but they're also going to be singlets.
E and B.
Okay, I don't have to distinguish which is which, but that's B or E. And what are these two?
C and D.
Okay, now on the test or whatever, you need to really clarify this. Something like this. This is what? Quartet 2H? Right there? Triplet 3H? Right there on the end. You know, I mean, this is aromatic. Basically, when I drew structures up here, that sort of helped.
So is it alright if when we get our final structure, we draw it off the side and label it with letters and the letters of the peaks, or do we have to draw the arrows?
You can do letters or arrows. Look in the answer key to the ones in the workbook. I have done them how I want you to do them on quizzes and tests. Okay, using arrows, letters. If you just put the answer and do nothing over here, you're not going to get much credit. I want to see your interpretation. At the same time, you can interpret and just miss one little thing. But if you have interpretation, I can give you partial credit. Okay? What's the structure of the like anion that would form? Likely not anion. Ion. It would be a cation. Of a likely ion. Loss of what? M minus what? What do you expect to lose?
The ether at the top right.
Everybody? Uh-huh. Nothing on the end. Main cation here, next to lone pair, M minus 15. Could show the cation. On the mass spec, I don't want to see loss of whatever. If you look in the workbook, I want to see actual structure. This didn't give you any particular mass. Typically ask for structure of the fragment that gives a certain mass. Okay. Aromaticity. The lab, we're doing the sulfur lab. The report will not be due next week because usually we don't do the sulfur lab until next week. I'm doing it a week early this time. So we're going to have to delay the report probably a week because we're not covering mechanisms yet. Okay. Sulfur report will not be due next week, but your so this week you're turning in your dial oxidation report. Also, we'll go over the carbon NMR portion, the predicting the values for carbon NMR. We'll go over that sheet sometime next week, like on Wednesday. Test on Monday, Yami, we're going to go in very similar format. We got nomenclature, there'll be some multiple choice. There'll be line reactions for predicting the product, or giving reagents, or giving starting materials. There'll be mechanisms, using arrows appropriately. There'll be multi-step synthesis, and there'll be a comprehensive spec file. There'll also be something that I'm forgetting to say now.
Will it be shorter since we only have 50 minutes versus?
It won't be too much shorter. No. Any questions about the test? You know the topics, what we got? Alkenes, all the topics we covered, right? Oxides. Aromaticity. Let's cover this handout in the 2 minutes we have left. 2 minutes or 5? Can't see. Okay, aromaticity. Wonderful world of aromatics. Okay, benzene ring. We've been ignoring it for a semester and a half. Chemistry. Some interesting reactions here. These are sort of advanced reactions, but the underlying principles are very basic. Questions: planar ring versus non-planar ring. When do we expect a ring to be planar, non-planar, etc.? Aromatic versus anti-aromatic versus non-aromatic terms. Down here are some experiments to run to determine if compounds are aromatic or not. Lots of these, please look ahead at this for Wednesday. Here's some drugs. Not only do we have for aromatic, we have the benzene, which is your granddaddy of all aromatics, and it's just a hydrocarbon. We also have rings that have heteroatoms, like nitrogen and oxygen. These are called heterocyclic rings. And heterocyclic rings can be aromatic, such as the thiophene ring. There's others, the parole ring, like in Lipitor. Of course, you have benzene rings, but that's an aromatic parole ring. Why is it aromatic? What structural features are we looking at to classify it as aromatic? Etc. Intro to benzene. Please, for Wednesday, please have gone over the aromatic nomenclature and be doing some reading about aromaticity. Okay? We'll hit the ground running on Wednesday. I wanted to do half a lecture today, but we didn't do it. See you after the lab this afternoon. Have a good weekend, guys. Okay, Mike.